Students, today we will do exercise 4.1 of determinants. Now, before the exercise, let us start with the introduction to the exercise. Now, first of all, what is a determinant? Now, to every square matrix A that equal to Aij of order n, we can associate a number, and that number can be real or complex, is called determinant of a square matrix A, where Aij is equal to ijth element of A. That means Aij means element in ith row and jth column of a matrix A. Now, what does this mean? This means that a determinant is a number associated to a matrix, and that number can be real or complex. Now, if there is a matrix A whose elements are A, B, C, D of order 2 by 2, then determinant A is written as determinant A that equal to determinant of A, B, C, D, or it can be also written as D, D, A, that means determinant A. Now, determinant of a matrix of order 1. Let there is a matrix A whose element is A, that means this matrix is of order 1. Then determinant of A is defined to be equal to A, means the determinant of a matrix with order 1 is equal to the element of a matrix. Now, second is determinant of a matrix of order 2. Now, if there is a matrix A of order 2 by 2, that is, and its elements are A11, A12, A21, A22. Now, this one A11 means element of first row and first column, A12 is element of first row, second column, A21 is element of second row and first column, and A22 is the element of second row and second column. Then the determinant of A is defined as DETA, that is determinant A, that equal to determinant of A, we are using symbol here, and that is equal to delta. Now, determinant A can also be written as delta, and that will be equal to determinant of the matrix A, whose elements were A12, A11, A12, A21, and A22. Now, if you want to find the determinant of this matrix, this will be equal to A11 into A22 minus A21 into A12. Now, let us take an example. There is we have to find the determinant of cos theta minus sin theta, cos theta. The delta is given to us and we have to evaluate it. Now, this will be equal to, now this A11 will be multiplied with A22, that means cos theta into cos theta minus sin theta into minus sin theta, and that will give us cos theta into cos theta will be cos square theta minus sin theta into minus sin theta will be plus sin square theta, and as we know, cos square theta plus sin square theta is equal to 1, so value of delta is equal to 1. Now, how to find the determinant of a matrix of order 3 by 3? Now, consider a determinant of a square matrix A, Aij, and this is of the order 3 by 3. Now, determinant A will be determinant of the matrix Aij. Now, we can find out the determinant of A by either expanding any one of the rows or any one of the columns. Now first of all, if we expand row 1, then determinant of A will be given by minus 1 raised to power 1 plus 1 mod of, now we are finding the determinant by expanding row 1. Now its element is A11, to this will be minus 1 raised to power 1 plus 1, and this 1 plus 1 is the element which we are taking. Now here this A11 is the element of first row and first column, therefore this minus 1 will be raised to power 1 plus 1. Now into the element, and element was A11, into determinant of, now for A11 we will eliminate the row 1 and column 1. That means we will not take the row and column of the element which we are taking. Now that will give us A22, A23, A32, A33. Now plus again minus 1. Now we are taking A12, so this will be 1 plus 2 into A12. Now this was for the first element of the row 1, and this one will be for the second element of the row 1. Into, now again for A12 will eliminate the row of A12 and column of A12, and that will give us A21, A23, A31, A33. Now plus, now one element is left in row 1, that is A13. Now this will be minus 1 raised to power 1 plus 3 for the element A13. Now A13 into, now again will eliminate the row and column of A13, and that will give us A21, A22, A31, A32. Now after we will solve this. Minus 1 raised to power 2 will be equal to plus 1 into A11, that will give us A11 into A22 into A33 minus A32 into A23. Then plus, now minus 1 raised to power 3 will be equal to minus 1. This will be minus A12 into, now again A21 into A33, A21 into A33 minus A31 into A23. Now this will be minus 1 raised to power 4 will give us 1, and 1 into A13 will be A13, that will be plus A13. Again we will cross multiply these elements, that will give us A21, A32 minus A31 and A22, and this will be equal to determinant A. Similarly, we can expand row 2 and row 3 as well. Now we can also solve the determinant, or we can also find the determinant of the 3 by 3 matrix by expanding the column. So I am expanding the second column. Expansion of column 2. Now if we want to expand column 2, on expanding column 2 of a matrix. Now this one was column 2, so its first determinant of A will be equal to -1, and we are taking the element A12. So this will be 1 plus 2 A12 into. Now again we will eliminate the row and column of A12, and that will give us A21, A23, A31, A33. Now plus again -1 raised. Now we have to take the second element of column 2, that is A22. So 2 plus 2 into A22 into determinant of. Now A22, so we will eliminate the row and column of A22, and that will give us A11, A13, A31, A33. Now plus minus. Now third element of column 2 was A32, that will be 3 plus 2 A32 into. Now again A32, that means we have to eliminate the row and column of A32, and that will give us A11, A13, A21 and A23. Determinant of A11, A13, A21 and A23. Now we will solve this, and that will give us -1 raised to power 1 plus 3, 2, that will be -1 raised to power 3, and that will give us -1 into A12 into determinant. So that will give us A21 into A33 minus A31 into A23. Now plus -1 raised to power 2 plus 2 will be equal to -1 raised to power 4, and that will give us 1. So 1 into A22 will be A22 into. Now determinant of this will be A11 into A33 and minus A31 into A13. Now plus. Now -1 raised to power 3 plus 2 will be -1 raised to power 5, and that will give us -1. -1 into A32 will be equal to minus A32 into determinant of this one will be A11 into A23 minus A21 into A13. Now if we expand row 1, row 2, row 3 or column 1, column 2, column 3, we will get the same value of the determinant. Now always keep in mind that for any matrix A, determinant of A, that is determinant of A is read as determinant A and not modulus A. This one is for any matrix. This is the sign for determinant A. Now second thing is that only square matrix has a determinant. That means we can find the determinant of a square matrix only. Let us take an example. Here we have to find the determinant of a matrix of order 3 by 3. Now we can find its determinant by expanding any row or column, but it is more convenient to find the determinant of a matrix by expanding the row or column whose maximum number of entries are equal to 0. As the first element of second row is 0 and third element of third row is 0, so we can either, it is more convenient to solve it by expanding either column 1 or row 2 or row 3, or you can solve it by expanding column 3 also. So here I am expanding row 2. So on expanding row 2, the value of delta will be equal to -1. Now we are expanding row 2. Now first element of row 2 will be, first element row 2 was 0, and that was row 2 first element. So -1 will be raised to power 2 plus 1. Now this first number is the number of the row and second number is the number of the column of that element into determinant of, now we'll eliminate the row and column of the element which we are taking. We are taking the 0 here, so we'll eliminate the second row and the first column of the determinant to, and this will give us determinant of -1, -2, -5, 0. Now plus -1. Now we are expanding row 2. The second element of row 2 will be 2. The second element of row 2. The row 2 second element. This first denote the row of element and second is the column of the element, and this it is in second row and second column. So -1 will be raised to power 2 plus 2 into 2. The element was 2. Now we will eliminate the row and column of the element we have taken, that is 2. After eliminating the second row and second column, we will get 2 minus 2, 3, 0. That will be determinant of 2 minus 2, 3, 0. Now plus -1. Now one element of row third is left, that is row third element and column third element. That means this will be row 2, element of row 2 and column 3. -1 is element of row 2 and column 3. So that will be -1 raised to power 2 plus 3 into -1 into, now again we will eliminate the row of -1 and column of -1, and this will give us determinant of 2 minus 1, 3 minus 5. Now this will be, now -1 raised to power 2 plus 1 will be 3. The -1 raised to power 3 will give us -1 into 0 into -1 into 0 will be 0 minus -5 into -2 will be equal to 10. Now -1 raised to power 2 plus 2 will give us 1. Now 1 into 2 will be equal to 2. Determinant of 2 minus 2, 3, 0 will be 2 into 0 will be 0 minus 3 into -2 will be equal to -6. Now plus -1 raised to power 2 plus 3. Now 2 plus 3 is 5. So -1 raised to power 5 will give us -1 into -1, and determinant of 2, 1, 2 minus 1, 3 minus 5 will be equal to 2 into -5 will be equal to -10 minus, now 3 into -1 will be -3. That will give us 0. Now 0 multiplied to any number will give us 0 plus 2 into 6 minus will be plus. Now -1 into -1 will be equal to 1 multiplied to -10 plus 3 will be equal to -7, and this will be equal to 12 minus 7, and so the value of delta or determinant will be equal to 5. Now we can also do it by expanding any other row or column. So I am doing it by expanding column 3 also. Now if we expand column 3, now I have written the determinant here. Now on expanding column 3, what we will get? Now on expanding column 3, now first delta will be equal to minus 1 raised to power. Now we are expanding column 3. This minus 2 is the element of first row and third column. So this will be 1 plus 3 into minus 2 into determinant of, now we will eliminate the row and column of minus 2, and this will give us 0, 2, 3, minus 5. So 0, 2, 3, minus 5 plus, now second element of third column is minus 1. That will be minus 1. Now second element, now this minus 1 is of second row and third column. So this second row and third column into minus 1, the element was minus 1 into, now we will eliminate the row and column of minus 1, and that will give us 2 minus 1, 3 minus 5. Now last element of column 3 is 0, and this will be minus 1. Now this 0 is of row 3 and column 3, so this will be 3 plus 3 into 0. Determinant of, now again we will eliminate the row and column of the 0, and that will give us 2 minus 1, 0, 2. Now this will be minus 1 raised to power 4 will give us plus 1 into minus 2, and determinant of 0, 2, 3, minus 5 will be 0 into minus 5 will be equal to 0, minus 3 into 2 will be 6. Now minus 1 raised to power 2 plus 3 will give us minus 1. Now into minus 1, determinant of 2 minus 1, 3 minus 5 will 2 into 5, that will be minus 10 minus 3 into minus 1 will be minus 3. Now plus, now if 0 is multiplied to any number, that will give us answer as 0, so we can directly write it as 0. That will be minus 2 into minus 6 plus, now minus 1 into minus 1 will be equal to 1 into minus 10 plus 3 will be equal to minus 7. That will give us 12 minus 7, and that equal to 5. Now as we see here, either we expand the row 2 or column 3, we are getting the same answer as 5. That means on expanding any row or column, the value of determinant will not change. So we can say that value of determinant of any matrix is always a unique number, either real or complex. Now come to exercise 4.1. Here we have to, in question number first, and in all these questions we have to find the value of the determinants. Now in question of first, the 2 by 2 determinant is given. In second also 2 by 2 determinant is given, and we have solved the first part of question number 2 in the example of 2 by 2 matrix, that how will we find the value of 2 by 2 matrix. Now I am doing the second part of question number 2 here. Now in second part of question number 2, we have to find the determinant of the matrix 2 by 2 matrix. Now for this, in 2 by 2 matrix we can find the determinant by cross multiplying the elements of the matrix. That means A11 will be multiplied by A22 and A21 will be multiplied by A12. Now here the determinant will be equal to x square minus x plus 1 multiplied by x plus 1 minus x plus 1 multiplied by x minus 1. Now on multiplying these two, we are getting x cube plus x square minus x square plus minus x plus x plus 1. Here minus x plus 1 x will give us 0, and x square minus x square will be equal to 0. Now x plus 1 into x minus 1 will give us x square minus 1. Now on opening the bracket, we are getting the determinant as x cube minus x square plus 2. Now in question number 4, the matrix A is given to us. This is a 3 by 3 matrix. Now we have to prove that determinant of 3A is equal to 27 into determinant A. Now A is given to us. We have to find determinant of 3A. Now for that, first of all, we will find the matrix 3A, and that will be, now matrix 3A means that 3 will be multiplied to all the elements of matrix A, and that will give us 3 into 1 will be 3, 3 into 0, 0, 3 into 1 will be 3, then 3 into 0 will be 0, 3 into 1 will be 3, 3 into 2 6, 3 into 0 0, 3 into 0 0, and 3 into 4 will be equal to 12. Now determinant 3A will be equal to, now here as we see, the two elements of row 3 are equal to 0. So we can solve it by expanding row 3. Now on expanding row 3, we will get minus 1. Now this 0 is of row third and column first element into 0 into determinant of, now will eliminate the row and column of this element which we are taking here, and that will give us 0 3 3 6. Now plus minus 1. Now we are expanding row 3. We will take second element of row 3, that is row 3 second element, and that was also equal to 0. And after eliminating the row and column of this element, it will give us 3 3 0 6, 3 3 0 6. Now plus minus 1 raised to power, now third element of row 3 third element was 12, and into determinant of, after eliminating the row and column of 12, we are getting the determinant of 3003, 3003. Now as we see here, now this first 0 multiplied by n number will give us 0, again 0 multiplied with by any number will give us 0. Now third element was minus 1 raised to power 3 plus 3, that is minus 1 raised to power 6, and that will give us 1. 1 into 12 will be equal to 12, and determinant of 3003 will be 3 into 3 9 minus 0 into 0 will be 0, and that will give us determinant as 108. Now value of 3A is 108. Now after that we have to find 27 into determinant A. Now 27 into determinant A. Now for that we will find out the determinant of A. Now in determinant of A, again that will be, determinant of A will be 1, determinant of 1 0 1 0 1 2 0 0 4, as matrix A was 1 0 1 0 1 2 0 0 4. Now here also we can expand row 1 or column 1, row third or column 1, as we have done in previous step. We have expanded row third, so it is more convenient to expand the row third or column 1. So here I am expanding column 1. On expanding, you can also expand column 3 on expanding column 1. Now first, so the determinant of A will be minus 1. Now first element of column 1 is 1. Now this one is row 1 and column 1 element, this one into 1. Determinant of, again this is 1 2 0 4, 1 2 0 4 plus, now minus 1 into second element of column 1, that is a 2 1, row 2 column 1 element, then this is 2 plus 1 into 0 into determinant of, now 0 1 0 4, 0 1 0 4 plus minus 1, now again 0 into 0. Now we are expanding column 1 to a third element of column 1 was 0, and this is of row 1 and column 3rd to row 1 and row 3rd and column 1. Now that was 0, and we will get the determinant of 0 1 1 2. Now again this will be equal to 0, and this part will also be equal to 0 as both are being multiplied by 0. So minus 1 raised to power 2 will give us 1 into 1, and determinant of 1 2 0 4 will be 1 into 4, 4 minus 0 into 2 will be equal to 0, and others will be 0. This will be equal to 4. Now that means, and if we multiply 27 with determinant A, that is giving us 27 into 4, and that equal to 108. And that means, so we can say that this determinant 3A was also 108, and 27 into determinant A is 108. So we can say that determinant 3A is equal to 27 into determinant A, which we had to prove. Question number 5th is same as question number 4th, and we have also done the 4th part of question number 5th in the examples. Now come to question number 7th. I am doing second part of it. Now here the two determinants are equal given to us. Now this is a simple question. Now we have to find out the value of determinant of both the sides. Now 2 into 5 will be equal to 10, and 4 into 3 will be equal to 12. The value of the determinant to this on the left hand side will be 10 minus 12, and that will be equal to, here also in right hand side the value of determinant will be x into 5 will be 5x, minus 3 into 2x will be 6x, and that will give us minus 2 equal to minus x, or we can say x equal to 2. Similarly, we can do question number 8, and here the determinant was x18 to x equal to 6 to 18 6. Now here this value of the determinant on the left hand side will be x square minus 36, and that equal to 36 minus 36, and we can say this will equal to x square minus 36 equal to 0, and this implies that x square is equal to 36, and we can say the value of x is root 36, and that will be plus minus 6. Thank you.